All right, ladies and gentlemen, it's time for us to go ahead and get started. If you have a piece of paper or a pencil, that would be great. Let's see what's going on. We're not showing up yet. There we go. All right, so we are going to be starting on double grouping today. Again, remember you do have Edgenuity available for you. Hi guys, good morning. This is a great tool though for you. We're going to try the comments, so if you have any questions, go ahead and send me a comment. Otherwise, you can text me via Remind or send me an email and I'll still get it that way. We're going to go ahead and start with our try this. So if you have a piece of paper or pencil, try this is where we're going to start. I recommend also having Desmos opened up. If you have it, I have Desmos opened up on my page. So let's just go ahead and take a couple of minutes, or maybe a minute, a few seconds, to go ahead and complete the try this. We're looking for what is the greatest common factor between each set of monomials. So for number one, we have 72x cubed and 30x. And for number two, we have 96x to the fifth and 88x squared. Let's go ahead, take about 30 seconds or so, and then I'm going to start working on it myself, okay? All right, so let's look. We have 72x cubed and 30x. If I pull up Desmos here, remember I type GCD parentheses and I type my two numbers separated by commas. The GCF between those numbers is 6. So 6. And now I've got to look at what about my x's. So I have x cubed and x. So I've got to look, what do they both have? What factor do they both have? They both have 1x, so that's going to be x. 6x is my greatest common factor for 72x cubed and 30x. So now let's take a look at number two. I have 96x to the fifth and 88x squared. If you haven't done so already, plug it into Desmos, 96, 88, and let's see what is the greatest common factor. So we have 96 and 88. Looks like there's a number. Greatest common factor is 8. And now let's look at our variables. We have x to the fifth and x squared. So what do they both have? They both have 2 x's, so that means x squared. Because x to the fifth, that means I have 1, 2, 3, 4, 5 x's. X squared means I have xx. They both have 2 x's, so my greatest common factor is x squared. All right. So this is basically what we're going to be doing today, but we're bumping it up an extra level to be doing double grouping. So first, with double grouping, we're going to group pairs with their common factors, because we're going to be given lots of terms. We're going to be given probably 4 terms, and we're going to have to group, okay, these 2 terms have common factors, these 2 terms have common factors. And then just like how we did in our try this, we're going to factor out that greatest common factor from each group, and then we're going to use the distributive property to write the polynomials as product of binomials. So we're going to factor out our greatest common factor and put it in the front, and then we're going to factor out our greatest common factor and put it in the front, and you're going to see we're going to get something kind of cool where both of these parentheses are the same, and then we're going to rewrite our parentheses to be the 2 greatest common factors out front, and then the other parenthesis left alone, okay? We can check our work by multiplying, and we will be doing that. These steps are mainly used for when we have 4 terms in our polynomials. If we have more than 4 terms, it gets a little weird and sometimes we do other things. But 4 terms, we can factor by grouping. So let's take a look. Here we go. I'm going to zoom in. It might be kind of blurry, but it's because of the way I'm writing on my computer. It's going to have to be a little bit more zoomed in. Okay, so here we have 4x cubed plus 14x squared plus 6x plus 21. So I have 1, 2, 3, 4 terms. So I've got to split these up into 2 groups. So let's go ahead. I'm going to highlight my groups here. This one, let's see if I can make this a little bigger. This one right here is going to be my first group, and I'm going to change the color. This one right here is going to be my second group. So I have my first group and my second group. All right, I'm going to look at my GCF for my first group. That's 4x cubed and 14x squared. So what could I use to find the GCF for the numbers? I hope you said Desmos because we can use Desmos. So I'm going to pull up Desmos. I need the GCF for 4, 14. It tells me that GCF is just 2. So first GCF of the first group is 2. Now I've got to look at my variables. I have x cubed and x squared. What do they both have? They both have x squared. Okay, they both have 2 x's, so they both have x squared. Okay, now let's look at our second group. I'm going to change my color so that it's a little different. Maybe I'll stick to blue, just like the highlighter. Okay, I have 6x and 21. So let's pull up Desmos. 6 and 21. Now remember, I can't put variables into Desmos because then it starts to get a little weird. So I can only put the numbers in. 6 and 21, it tells me their greatest common factor is 3. So that means my second group is 3. And I have x and no x. So do they both have variables? Do they have a greatest common factor of variables? No, because I have just one x on the 6x, but I don't have an x on the 21. So my greatest common factor is just the number 3, and that's it. So now what I'm going to do, now that I found my greatest common factor of both groups, I'm going to write it out and factor out my greatest common factor. We did a little bit of this before, so let's go ahead and start writing it out. So my first group is going to come first because it's first. So I have 2x squared. All right, that is my GCF. Remember, GCF goes on the outside of the parenthesis. What is going to be left on the inside? I've got to divide out or factor out my GCF. So 4 divided by 2 is 2. If I have x cubed and I take away x squared from x cubed, so that means I have 3 x's, and I'm dividing out 2, I'm left with 1x. I keep my plus sign. 14 divided by 2 is 7. X squared, I'm taking away x squared. So x squared, take away, do I have any x's? So I have 2x plus 7. Now let's look at our other group over to the side here. My other group, my GCF was 3. So now I've got to divide each term by 3. So I have 6 divided by 3. 3. And what happens to that x? It just stays. You're right. I keep my plus sign in the middle. 21 divided by 3 is 7. Whoa, whoa, whoa. Nobody corrected me. Granted, I couldn't hear you. My brain, it's too early in the morning. There we go. This should be a 2. 6 divided by 3 is 2, not 3. I'm thinking addition, I guess. My brain's just a little weird this early. Okay, so I should have 3. 6x divided by 3 is 2x. The x just stays. 6 divided by 2 is 3. And then 21 divided by 3 is 7. If you look, there's something that's very interesting that we have here. If we look at this guy and this guy, what do you notice? I hope you said they're the same, because they are. So that means we're going to factor out that 2x plus 7. This is now my greatest common factor. So I'm going to divide each term. So I'm going to divide this side and this side by 2x plus 7. So that means my 2x plus 7 is going to come out right here. These are some fun colors. 2x plus 7. And what's left over? Well, if I take 2x plus 7 and I divide it out of here, what do I have left? 2x squared. Perfect. And then if I take, I'm going to change this color again, 2x plus 7 and divide it out of here, what do I have left? A positive 3. There we go. So this tells me that my factors are, when I factor out by grouping, this is my answer. 2x plus 7 times 2x squared plus 3. Now, the last step of this, to make sure that I did my factoring right, is to multiply it out to make sure that I get this answer up here. So should we multiply? You guys remember? It's been a couple weeks since we've multiplied, but we're going to go ahead and set it up. Okay, so I'm going to draw out my boxes. You might draw out your boxes a little bit differently than me, and that's fine, but here are my boxes. Okay, I have a 2x right here, line to separate my terms, a 7 right here. I have a 2x squared right here, line to separate my terms, and a 3. So now I'm going to multiply. I have 2 times 2, which is 4. X squared times x, that means I have x squared and I'm adding another x, so I get x3. Now I'm going to change colors. I have 3 times 2, which is 6, times x, because x is left over, so I have x. Now I'm going to move on to the bottom here. 7 times 2, 14. I have just an x squared left over. And last, I have 7 times 3, which is 21. Okay, do I have any like terms in my boxes? Nope. I have 1x cubed, I have 1x squared, and I have 1x. They're all separate, different terms. I do not have any like terms. So all we have to do is write it out. Largest exponent to smallest exponent. So here we go. My largest exponent is x cubed. So 4x cubed comes first. My next highest is x squared. So plus 14x squared. And my next highest is x plus 6x. Ooh, that was a little weird. It's okay, you know what it means. And last comes plus 21. So let's look. I have my factors, 2x plus 7 and 2x squared plus 3. When I multiplied them out, this was the answer that I got. 4x cubed plus 14x squared plus 6x plus 21. Let's see, is that the answer that we had, or is that the correct equation that we started off with? 4x cubed, whoop, I moved it too much. There we go. 4x cubed plus 14x squared plus 6x plus 21. Are we good? Are our factors, do they work? When we multiply it out, is it the same? Yep, so that tells me right here that this guy, I'm going to do it in green. No, I'm going to stick to the yellow. This guy right here is my answer. All right? Are you ready to try another? Because it does get a little trickier. You ready? Here we go. Let's take a look at number 2. Yes, the remind code is Atwood's algebra. It's the same. Atwood's alg. Gavin's got it. I was trying to find it for you guys while explaining at the same time. Didn't quite work. All right. Okay, let's see if you guys can find the greatest common factor of each group. This one's going to be tricky because let's look at our second group. Maybe I should just do this one with you guys. Let's see. We'll be okay. Let's look. My first group is, what do you think? What two numbers or what two terms are going to be a part of my first group? If you said 12x cubed plus 4x, you are perfectly correct. Now my second group is going to be, I'm going to do this light green, negative 9x squared minus 3. Okay? So the first group, go ahead, find your GCF for the first group. Okay? I'm glad to see that the messaging is working today, or the chat, except I'm so focused on this side of the screen, I sometimes miss your guys' messages. But okay, GCF, I pull up Desmos here. GCD, I have 4, 12. What is my greatest common factor between 4 and 12? It is 4. Ooh, that was a weird 4. There we go. Okay, and then I have x cubed and x. What do they both have in common? Just one x. Okay, this is where it's going to be tricky. I have negative 9x squared and negative 3. We didn't talk about this one last time. How if the first number has a negative, so our 9 has a negative in front, that means we've got to factor out a negative out of both parts because we want to get the negative away from the first part. So away from the first term, because we don't want to start with a negative, okay? So negative 9, I want to factor out the negative. So the first thing I'm going to write is a negative. So I have my little negative sign. Now I'm going to look at 9 and 3. What is my greatest common factor for 9 and 3? If you don't know, Desmos is a great tool. Let's do 9, 3, and we've got 3. So I'm going to have a negative 3. That is my greatest common factor. Now I have x squared and nothings. Do they have any variables in common? No, they do not. So now I'm going to keep working just like my other problem, the one we just did. So I'm going to zoom in a little bit so that I can write it a little more clearly. Here we go. All right. So my GCF of the first group is going to come out in front of the parentheses. So I'm going to write, don't know if you can hear my puppy. He almost pulled the whole computer down for a second there. For x, GCF comes out in the first group of the parentheses. First group, GCF of the first group comes out in front. Now, when I take out or factor out, because you're going to hear factor out a lot. Now, factor out just means divide out 4x. If I divide 12x cubed, divide by 4, that is 12 divided by 4 is just 3. X cubed divided by x, so I have 3 x's. I'm taking away 1. I'm left with 2. So x squared. Now I'm going to be looking at 4x divided by 4x. 4 divided by 4 is 1. If I have 1x and I'm taking away 1x, 4x divided by 4x is just going to be plus 1. Okay, now I'm going to go ahead and write out the next group. So let's see. My GCF of the second group is -3. -9x squared divided by -3. So -9 divided by -3 is +3. So I'm going to have a +3 right here. Ooh, that was too big. There we go. Is anything going to change to my x squared? Nope, it's going to stay the same. So I'm going to have x squared. Now, -3 divided by -3. Negative divided by a negative is a positive. 3 divided by 3 is, so -3 divided by -3 is +1. Good. Okay, so now if we look, we have our two factors that are the same. So now I'm going to be factoring out my 3x squared plus 1. So that means 3x squared plus 1 is going to come out front here. Oops, sorry, bumped the table. 3x squared plus 1. I took it out of each part. So that means my first term, 4x times 3x squared plus 1. If I factor out that 3x squared plus 1, what is left over? 4x. Okay, let's look at the second group. -3 times 3x squared plus 1. If I pull out 3x squared plus 1, what is left over? -3. Okay. So this guy right here is going to be my answer. We could check it by multiplying. If we wanted to check it by multiplying, refresh. How do we do that? Set up our boxes. 3x squared on the side here. 1 line to separate them. I have 4x. Line to separate my terms, -3. 4 times 3 is 12. X squared times x. X cubed, because I have 2 x's plus 1 more. Now 3x squared times -3. -9x squared. 1 times 4x. 4x. 1 times -3. -3. Good. So now if I write it in order from largest exponent to smallest exponent, let's see what I'm going to get. 12x cubed, that is my largest exponent. My next highest exponent is negative 9x squared. Next highest is plus 4x. And next is minus 3. All right, what do you notice about our answer and our original problem? Are they different? They're in different orders, but they are the same thing. So I still have a 12x cubed, I still have a negative 9x squared, I have a plus 4x, and I have a minus 3. So we're good. Check mark. We're good to go. So let's go ahead. I want you guys, let's look at number 3, and then we may cut it off. Number 3, and then we'll practice more tomorrow. All right? So here we go. Number 3. Actually, I might jump to a different one. I think I might jump to number 5. I want to practice number 5. Okay, here we go. Number 5. Oh man. We're refreshing. Come back. Okay, this is the longest it's ever taken to refresh. There we go. Okay, let's take a look at number 5. Here we go. Last one, and then you guys will be doing your warm-up and instruction video on Edgenuity, and tomorrow we'll do more practice with this again. Cool? Okay, number 5. We have our two groups. Let's see. If I separate my two groups like this, if I separate them with x cubed minus 2x squared and negative 3x plus 6. Do I have like terms in both of those groups? Do I have greatest common factors? Do I have like factors? I do. I have like factors in both groups. So what do you notice about that negative 3 though? That negative 3 is going to have to come out, so I'm going to have to divide out by a negative. All right, so let's find the GCF of the first group. See if you can beat me. I'll give you guys a head start. So my first group, I have 1 and negative 2. My number, if I was to plug that into Desmos, 1 and 2, 1, comma 2, my greatest common factor is just 1. So now that means all I have to do is look at the variables. I have x cubed and x squared. What do they both have? X squared. Okay, let's look at the next one. Negative 3x and 6. I have a negative in front. I have that negative 3. So that means I need to pull out a negative. If I look at my numbers now, 3 and 6, what is the greatest common factor between 3 and 6? GCF. GCD 3, comma 6 is 3. Now I have 3x and no x. Do they have a variable in common? Nope. So my greatest common factor is just negative 3. So I'm going to write my GCF of the first group in the first spot, x squared. And I'm going to divide it out or factor it out. So x cubed, factor out x squared, x cubed. I'm taking away x squared. How many is left? just x. Negative 2x squared. If I factor out x squared, what is left? Negative 2. Okay, my second group. My GCF is negative 3. Okay, if I factor out negative 3, so I have negative 3x, divide by negative 3, what is left? X. I have a positive 6, divide by negative 3, so I'm factoring out the negative 3, what's going to be left over? 6, factor out negative 3, so 6 divided by negative 3, negative 2. So now I'm going to factor out my like term, which is x minus 2. That guy's going to come out to the front. Factor that guy out. What is left over? In my first term, x squared, what? X squared times x minus 2. If I factor that guy out, what is left over? X squared. In my second group, negative 3 times x minus 2. If I factor out x minus 2, what is left over? Negative 3. Gavin, I'm going to come back to your question after this one. Okay, you can check this by multiplying and making sure that we still get x cubed minus 2x squared minus 3x plus 6. You can multiply it out and make sure that that's really what we get. But I'm going to tell you right now that this is right. I worked it out earlier today. So this guy right here is our factored by grouping. That is our answer. All right. Okay, if you don't have any other questions. Okay, Tatiana, what do you mean by if the numbers if the numbers in the parentheses aren't the same, how would we solve it? Oh, so if you're meaning if we had x minus 2 and x minus 2, if they weren't the same, then we wouldn't be able to factor it out. So we wouldn't be able to factor out this x minus 2. We would have to look back, make sure we have the right GCF, because sometimes our GCF is wrong, and make sure that we factored out our GCF correctly to make sure that we're getting parentheses that look the same. If we make sure and we find that our GCF is right and we factored it out right and it's all good to go, but we still end up with two different parentheses right here, Coda, then maybe we aren't going to be using double grouping. We're not going to be factoring by grouping. Okay? Now, Gavin, to answer your question, how we got negative 3, we, in our second group, our GCF was a negative 3 because we had this negative right here in front. So because we have a negative in front, that means we're going to be pulling out a negative. Okay, and then we looked at 3 and 6. Our greatest common factor for 3 and 6 is 3. So that's how we got our negative 3. Then when we pulled out our x minus 2, we were just left with x squared and minus 3. All right. Okay, I'm going to go back to number 2. If I see we're good to go. I think I'm ahead of you guys a little bit more because I can see you guys are just going over one of the parts I just talked about. So let's take a look at number 2 here. Sweet. Awesome. All right. For the 4x minus 3, Gavin, I did the same thing. I think you'll be able to walk yourself through that one now after we did the extra walkthrough on number 5. All right? Okay, guys. There is a delay. I know. It's crazy. All right, guys, if you have any other questions, I'm available on Remind. You can send me a picture of what you're working on and I'll help you out. Otherwise, we'll do another video. We'll go over these next 3 problems tomorrow because you guys are working on double grouping for the next couple of days, okay? So today, if you're in my class, and I believe in Miss Bernardi and Moloch's class, you will be going over 8.2 warm-up and 8.2 instruction, and you have some Delta math. I think Mr. Languel is doing the same thing. All right, guys? Have a good day. Reach out to your teachers if you have any more questions, okay? Bye. Okay, maybe if I can exit out. We'll see. I lost my little mouse. Bye, guys.